All right, the next one we're going to go over is incomplete dominance. So in the case of incomplete dominance, before we were always talking about when there are two alleles, there's going to be one that's dominant and one that's recessive. There are cases, however, where when there are two alleles, neither of them are really dominant to each other or recessive to each other. It's called incomplete dominance. Okay, so when they are put together, so for example, if you have a red snapdragon that's dominant in its own, and then you have a white snapdragon, they are incompletely dominant over each other. So when you breed them together, you get that red allele and that white allele. And so when they're RW, they're actually this intermediate color or this blended color, which is pink. Back in the day, they used to think this was an issue because they'd be like, well, if it's just blending, it's just a new theory. But then when they bred the pink flowers together, they also had flowers in the offspring that were red and white and pink. It wasn't just all pink from then on. So this idea of incomplete dominance became proven when they breed multiple generations. You can see that the original parental generation traits come back in. So like I said, in this example, if you breed an RR red snapdragon with a WW white snapdragon, you get RW pink snapdragons. So you're like, oh, blended, cool. That automatically means incomplete dominance. But it's important for you to note that it's not actually blending because in the next generation, when you breed those RW pink ones, you get some RR red, some RW pinks, and some WW white snapdragons in the next generation. Okay, so keep that in mind. But if you see blending or mixing, it probably is an incomplete dominance example. So let's do one together. So in a certain species of fish, blue scales, capital B, are incompletely dominant to yellow scales, capital Y. Notice they're both capital because they're not related to each other anymore, but they're also not dominant over each other because they're both capital. So if you cross a blue fish with a green fish would be BY because it's that blended color in between, right, for incomplete. How many offspring will be yellow? Now, I want to make a note on the question as I transition from going to show you the workspace that I'm working on. So the question said, how many offspring will be yellow? And that's a bad question. Okay, you won't be asked that on the start. You can only predict a chance in Punnett squares. You can't tell me how many. Okay. How many kids you have, how many kids another couple has, how many kids an animal or a plant species makes out of a pairing, you cannot tell. You can only tell the percent chance of when the next offspring is born or hatched or made. What is the chance that it will have this or that phenotype, okay? So we're crossing a blue fish and a green fish. So you're gonna wanna set up a Punnett square. And that Punnett square, obviously you need the square. And we're gonna put the blue fish up top. So that blue fish is a capital B. And that green fish is gonna be capital B, capital Y. And so when you do the Punnett squares, you end up with this as your result. And the question, remember again, was asking you how many offspring will be yellow? Now, if you look in here, you should already be able to tell right away. Are there any yellows? Right, because the yellow is supposed to be capital Y, capital Y. Therefore, you should have your answer right away. So you're not telling me how many will be yellow, right? You're not saying 0 are yellow. You're telling me there's a 0% chance that these offspring will be yellow from this cross, maybe in another cross, okay? So we're gonna go back now and we're gonna go to the you do section. So they're doing flowers again. If red flowers, capital R, are incompletely dominant to white flowers, capital W, what are the possible offspring genotypes of a cross between two pink flowers? So pink flowers would be RW crossed with RW. So you're going to do your Punnett square and tell me, what could the offspring look like, right? What could they be? RR? Could they be RW? Could they be WW? Could they only be RR? Could they only be RW? You have to figure that out with your Punnett square to see what are the possible genotypes that these offspring could be.